In this interview, we talk about how Netflix scales to handle over 36% of the nation's downstream bandwidth during peak hours, how Reddit handles over 160 million uniques a month, and billions of page views. How do you track errors in development, and how do you know when your users run into errors? Do you even have an error tracking strategy? Mine was terrible, but I found a solution that I really like. Rollbar is an incredible product, and I'm not just saying that because they're sponsoring the show. I'm actually using Rollbar at Scale Your Code. I'll tell you more about that later in this episode, but go to try.rollbar.com/SYC and set it up with your app. It's really easy. It took me 5 minutes, and it works with any language and any tool you need. Try.rollbar.com/SYC. Hey fellow coders, my name is Christoph. I'm the host of Scale Your Code, where ambitious and successful developers teach us how they do it. Today's interview is going to be really interesting because we have two giants with different technical difficulties. And today's guest, Jeremy Edberg, is going to explain to us how he overcame these difficulties and scaled these sites to incredible heights. Jeremy was the first paid employee and chief architect at Reddit and the reliability architect at Netflix. He's also created his own company called CloudNative. We're going to be talking about all three of these in chronological order so we can more easily compare and contrast them. Jeremy, welcome to the show.
Thank you. Good to be here.
So tell us about the story of how you got started with Reddit. How did you become the employee number one?
So that's a pretty funny story, actually. I went to demo day, or not demo day, startup school in Boston, the very first startup school for Y Combinator. And I ended up meeting the Reddit guys there, which was intentional because I had actually had sort of a similar idea. And then when I Googled around, I found Reddit. And so I had joined Reddit. And so I'd been on Reddit for a couple months. I flew out to Boston, and I got invited to this like pre-party thing. And I thought that it was a mistake when I got there because everybody at the pre-party was either part of Y Combinator or one of Paul Graham's friends. I found out later I was basically invited because I was one of the few people there who was older than 30, basically. But yeah, so I ended up meeting the guys there. We hung out, and then we had lunch shortly, on the last day of that startup school, and I handed them my resume, and I'm like, hey, I really want to work for you guys. And they took it, and they were like, we don't know what to do with this. Like, we've never hired anybody before. And so we ended up just chatting, being friends. They came out to California a few times, and I put them up in my apartment, and then eventually they got acquired by Condé Nast and was able to hire me full-time.
How long after Reddit started did this happen?
Well, I met them just a few months after it started. I ended up working for them in March of 2007, which was about a year and a half after they started.
I see. So that's why you were the first paid employee there. Okay.
Yeah,
that makes sense.
Yeah. Everyone else was basically a founder or sort of a co-founder.
Okay. Let's dive right in. And can you give us a general overview of what the Reddit architecture looks like?
So I can tell you what it looked like when I was there, when it started. So it was basically it's Python, and the app servers are Python, and everything hits the Python directly through an HA proxy load balancer. So the request comes in, hits HA proxy, gets farmed out to the Python app. The databases are all Postgres, and then there's also a set of Cassandra cluster and a Memcache cluster. So depending on what data you're looking for, you're either going to hit, one of those three. And then, of course, the cache will be filled up. So that's the basic architecture of Reddit.
Do you know if that has changed a good bit, or have you kept in touch with that?
From what I understand, actually, I was just talking to them yesterday, and they basically have the same architecture now. They've made a bunch of improvements to the code, and there's stuff in there now like Zookeeper to help keep track of some stuff. But for the most part, it's basically the same concepts.
So I want to break those down a little bit more in just a little bit. But first, can you tell us some of the technical challenges that you ran into that just took down the site you were not expecting at all? What were some of those?
So basically, the way we scaled the site was we would go until we hit a scaling point, and there would be a failure. Some of the failures just had to do with the way that we were doing caching. We had bottlenecks there. One of the things that we had to solve eventually was rendering. So we used Markdown, and we were using a Python Markdown library, and it was just too slow to keep up. So we ended up actually getting first we found a C library that we made into a Python module.
Mm-hmm.
And then there was somebody actually created one called Discount, which is what we were using, and I think they might still be using today, but I'm not sure. You could actually check in the open source code.
Mm-hmm.
But basically, that was how we dealt with some of the scaling issues. So Markdown and was put into a C library, as was database access and memcache access were all done via C libraries. So those were some of the challenges there. One of the other big challenges we had was when we moved from a data center to the cloud, the latency between servers went from 1/10 of a millisecond to a millisecond, which doesn't sound like a lot, but when you have architected your software to make thousands of memcache calls per page load, that delay adds up. So we had to quickly re-architect to start using more larger batches of data and things like that.
Now, this was a few years ago. Do you remember what year you switched from that physical data center to the cloud?
Yeah, that was in May of 2009.
2009. Okay, so a few years back. Would you say that you still have some of those latency issues to this day, or has it improved?
There's always going to be a little bit of latency in a virtualized environment versus bare metal. But at this point, it's been architected around. So it's a known quantity, and so you just architect around it.
Mm-hmm. And it's funny, you just said that with the Reddit, at least at first, the mentality was, we'll scale when we start hitting bottlenecks. And from what I understand and from the research I've done, that's a very different mentality from at Netflix, where you're trying to figure out what the bottlenecks are going to be before they happen. So that's going to be interesting to see the difference between that. Do you think that's an accurate comparison to make?
Yeah. Yes, so Netflix, we definitely invested a lot more in testing, particularly around that kind of testing. At Reddit, it was more a function of we only had a staff of 5-6 engineers, and so we just didn't have a lot of time to do squeeze testing. Usually the bottlenecks were found by the users before we ever got around to finding them ourselves.
Sure.
I mean, we did find some ourselves. Like we would definitely use Python profiling extensively, which helped us find a lot of bottlenecks before they became problems.
Mm-hmm. So at that size of a company with that few employees, would you say that it's more important to focus on the features first and go with that approach of, when you hit the bottleneck, go ahead and fix it? Or should you think about the bottlenecks first and think about scale from the get-go? What do you think about that?
So I would say the smart person at least puts some thought into scaling, but doesn't prematurely optimize. Good software written well will at least handle a lot of the scaling issues sort of by nature. So there's something to be said for starting off with a good architecture. But that's really more of a business decision. But in my mind, it's better to move forward on the features than the scaling. But you do have to find the balance, because if your scaling is so terrible that your site is always down, then people just aren't going to use your product anyway.
Right.
So you definitely need to find the balance between, when to focus on which thing.
So you talked about profiling, and that goes in with monitoring and that sort of thing. So let's say, for example, we have somebody listening that has a very similar website to Reddit, and they do have a small team like that. What should they be focusing on monitoring? What kind of things would you say?
So my general advice with monitoring is to monitor application metrics. You can monitor server stuff and all that, but those aren't going to be as useful to you, especially if you're in the cloud, because you can just delete those instances. So generally, the things to monitor are the application metrics that matter to your business. Now, finding what matters to your business, is important. At Reddit, at least when I was there, what mattered was page views. So our main metric was page views per second.
Okay.
At Netflix, the main metric is play starts, how often someone successfully starts playing a movie. And so that was like the number one metric that was watched, was the starts per second. And those were good leading indicators, or sometimes trailing, unfortunately, of a problem. Where, if that number dips down suddenly, then that something is wrong. Because normally it's very smooth. It's a very smooth curve. And so that was kind of how monitoring happened, right? Is you look at those high level application metrics, because at the end of the day, it doesn't matter if your server is, spiking its CPU all the time if it's still serving customer traffic.
Right.
So it's really more about the customer experience.
Can you remember a time when there was a dip in page views per second, and how did you debug that? How did you fix that problem?
Well, so it happened a lot.
Right.
And debugging usually involved first checking to see if something had just been deployed,
Right.
then running to the logs to see if there was anything obvious in the logs. Eventually, we actually built a system that would fingerprint Python error messages, and so it would tell us anytime there was a new one, and it would give us the counts of every type of error message that we saw.
Oh, okay.
And so you could check those to see if a certain type of error had suddenly gone up. Otherwise, you would look at, we would have the monitoring that would show every server, and so you could quickly scan through that and see if any of them had, spiked CPU or had disappeared or something like that.
I see.
But I mean, typically the answer was in the Python logs. Maybe about half the time. About half the time, the answer was, "Oh, this server is under severe load."
Okay.
Another thing that we actually monitored a lot was queue length. So everything that could go into a queue, we try to put into a queue. So like incoming votes, incoming comments, things like that, they're all in queues. And so monitoring the queue length worked out really well, because then we could, that was a good indicator that there was a problem. If the votes queue had backed up, we knew that there was probably a problem with the vote database, for example.
What queue did you use?
We were using RabbitMQ.
RabbitMQ, okay. And you were using Postgres for the database, right?
Yeah.
And Reddit is pretty well known for using key value storage for part of its data storage. Can you walk us through the process of why you decided to go that route? Because it seems to me like Reddit has a lot of relational data, like users' votes, users' comments, users' posts, things like that. So what was the decision behind choosing to go with key value, especially with Postgres?
So I don't really know why Steve chose that, but it turned out to be a great choice. It turned out to be great for scaling because it let us, scale the databases independently, which was really nice. So there was, when I left, we had like 19 common databases and only 2 user databases, and we had 2 vote databases, but we really only needed 1. So it just depended. The data is relational in the sense it's not relational in a typical sense of relational. There are a lot of relationships, and if you look at the database structure, there are tables that are dedicated specifically to keeping track of relationships, but those are all totally storable in key value store, right? So your key is one thing and the other thing, and then the relationship between them. So it's actually storing that kind of relationship data is actually very conducive to a key value store.
I see. So if you could go back in...
But yeah, we were using Postgres as basically a key value store.
So if you could go back in time, you'd still choose to do that?
Oh yeah, for sure.
And why Postgres instead of something like MongoDB, for example?
Well, 1, because Mongo didn't exist at the time. But 2, because Postgres is just a really good, solid database. It has 25 years of practical use. It's the cleanest code you'll ever look at. It's super solid, and it's more performant than most of those other databases. Even when it's not doing relational work, even when it's being used as a key value store, it's still more performant than most dedicated key value stores.
So would you still use Postgres to this day, even though there are alternatives now?
I would, because a lot of the alternatives are either not battle tested, hard to maintain, or have some other negative against them. So even though Postgres isn't designed for key value, it works really well that way.
I've seen a lot of debate between people concerning MongoDB recently. A lot of problems with security issues and how long it takes to fix those, and just
So MongoDB is a very special case. It's one that I would never use, only because their developers have the first few versions of Mongo all had this problem where they put speed over durability. So the write would be marked as completed even though it hadn't actually finished writing to disk yet, for example. So you could lose it even after it told your app, hey, this write successfully completed. They've fixed that since, from what I've heard, but nonetheless, their attitude was speed over durability. And for a database, I really prefer durability over speed.
Is there an alternative that you could share with us?
For Mongo? Yeah, Postgres is actually a
Postgres,
really
you,
good
you
alternative.
still go, yeah,
Yeah.
sure, sure. Oh, by the way, what kind of tools do you recommend for monitoring?
So that's a really good question. It depends. If you are trying to run in like a cloud distributed
Hmm.
environment, you really need a good distributed monitoring system, and there aren't a lot of good ones out there right now. There's Netflix has actually open sourced their monitoring system, Atlas, which is designed from the ground up to be
Hmm.
great for use in the cloud. You could try that. There's a company called SignalFX that makes a commercial version that's very similar to
Okay.
Atlas. Uh, but like I know that the Reddit guys, for example, are using Graphite. I've seen Graphite a lot.
Hmm.
Graphite is pretty nice.
Yeah.
When I was at Reddit, we were using Ganglia, which is great for monitoring large groups of machines, but not so great for a cloud environment where they're coming in and out of service all the time.
Okay. So, just to be clear, did you leave Netflix and you're now full time in Cloud Native? Is that right?
Yeah, yeah. So I left Netflix back in February,
February.
and co-founded CloudNative about a month ago.
Okay, I see.
Well, CloudNative already exists, and I joined as a co-founder
Oh,
about
I
a month
see.
ago.
Okay. Okay. Yeah, I
Yeah.
definitely want to talk about that in a little bit. So when you have a big database like Reddit has, how do you back that up without causing downtime?
So that was not easy. So the backup strategy at Reddit is every database has at least one read slave,
Okay.
and so the backups come from the read slaves. They're dumped, PG dump off the read slave during low traffic
Hmm.
periods. So that worked really well when I was there because there was a very distinct low traffic period. As they get more and more global, it's going to be harder and harder to do that. It basically just means they'll need more read slaves
Hmm.
so that they can handle the losing one of them for backup.
Hmm. And how much of that data could you actually cache?
So the beauty of Reddit is that it's we were cheating basically. The hot set is extremely hot. Basically, everything that's on the front page today or yesterday is what's in the cache,
Hmm.
because that's what 99.9% of the people are looking at.
Hmm.
So it was actually caching. It was a fairly easy thing to do because there isn't really a long tail.
I see.
And you can see that when you try to load up an old page, that it'll take a while to load because none of it's in the cache.
I'll have to try that out actually. I'm not sure if
Yeah,
I'm sure I've done that before, but never really looked for it. I thought maybe it was my internet or something. I'll have to go back and
yeah,
actually
no,
look for it.
don't do that too
Right.
much though, because then you're just gonna slow everything down because it's gonna hurt the
Sure.
databases.
Sure. And
In fact, that was one of the scaling issues we had to deal with because Googlebot would come
oh.
through and scrape all of the really old
Hmm.
stuff, and so we had to rate limit Googlebot. And I think what they've now done is actually created like they'll lock a page after 6 months or something, and so then that loads much faster because it doesn't have to re-render everything.
Hmm. Hmm. Why did you guys end up using Cassandra? Hmm.
Why? So we were using this product called MemcacheDB, which was basically Berkeley DB behind Memcache, using the Memcache protocol.
Okay.
And that was working really well until it just stopped working really well. Uh, and there was no easy way to scale that.
Hmm.
The only way to scale it was to like double the size of your cluster and have a lot of duplicate data. So that sort of was the motivator for us to look into a more scalable distributed key value store.
I see.
And that's how we got into Cassandra. Looking back, we probably got into Cassandra a little early. We got in at like version 0.4 or
Hmm.
so. So that was probably a little early. It was kind of a pain to admin at that early stage, but it worked out because it was essentially at first just used as a
Hmm.
cache. Now I think it actually has data that's unique data. But at the time we started using it, none of it was unique. We could regenerate everything in Cassandra. It would take a long time to do it all, but we could theoretically regenerate everything that was in there.
I see. And I've read that it has really fast negative lookup. So
Yes.
do you know if they still use that to look up voting?
Also, that was one of the big improvements that helped is by having all of the votes in Cassandra. So when you load a comments page on Reddit, there's like 1,000 comments there, and we need to know how have you voted on every one
Right.
of those comments. Chances are, especially if it's new to you, you've never voted on any of that. So it's very nice to be able to go in and get very fast negative lookups on those 1,000
Hmm.
items. We actually put in a second hack where we would record in the user database the last time you interacted with Reddit, like if they voted, commented, whatever, And so if you load up a comment page that's newer than the last time you interacted, we wouldn't even have to go to the database at all because we know you could not possibly have voted on any of that
Right.
stuff. So that was actually a pretty big, that was a good scalability hack right there, was sort of keeping track of the last time you interacted with the site at all let us shortcut a lot of database lookups and cache
I
lookups.
was actually wondering how you did votes like that. It seems like it could turn into a very complex and very resource intensive process if you don't do it right. So that's pretty interesting.
Yeah. Yeah, so there was that, and then the fast negative lookups help a lot
Mm-hmm.
because since it does that because it has a Bloom filter on there, so it never actually has to hit the database.
Okay.
It doesn't have to pull in the data. It could just say there's definitely no data here.
So what other kind of data did you use Cassandra for?
Uh, what else was put in Cassandra? So Cassandra, one of the big things that it had was like caches of listings.
Okay.
So we would render, say, the listing page for our programming,
Mm-hmm.
and store, what are the 20, it would actually store 1,000 links.
I
So it would
see.
say, what are the top 1,000 items that we just picked out? And it would store that entire list of 1,000 items in Cassandra.
Mm-hmm.
And then essentially there was a queue. Every time a vote came in for programming, we would recalculate the 1,000 links for programming.
Okay.
Now, of course, that calculation took longer than the speed which the votes came in. So what would end up happening is a bunch of votes would come in, and it would get recalculated, and then anything that came in the interim would just get thrown away because we'd already sort of accounted for that. So that's how we kept up with recalculating. And then when you actually load our programming, what you're getting is that item, that 1,000 item cache.
Mm-hmm. Now here's a question from the community. I actually reached out to Reddit this time and asked them what they wanted me to ask you. So here's a question from user FUKITOL-, and the question is, what techniques were employed in future-proofing the architecture to ensure scalability as usage increases?
So I assume they're talking about Reddit.
Yes. Mm-hmm.
At Reddit. So I don't know if we put a lot of distinct thought into future proofing. What we put thought into was how do we make this scale as far as possible. And so using the key value store was one way to do that. Trying to do it wasn't called 12-factor app at the time, but kind of following some of those practices. Shared nothing. Each app server was independent. There wasn't any state saved in the app server, for example.
Okay.
Which actually ended up being a scaling problem as well, because then you have to make sure that your cache can handle, your whatever third place you're saving all your state needs to be robust enough to handle it. But that was the big one, is the shared nothing. Every app server at least is easily replaceable. All of them are equally good. So that was one way to do it. We basically made it so that we could just bring up more app servers and horizontally scale that portion. The database is not quite as easy to scale up, but making it having support for read slaves helped a lot, because then as the load got higher, we could bootstrap a new read slave to alleviate a lot of the load. One thing we ended up doing after a while was making the master database only for writes. So you could only write data to it. It would never be read from.
Right.
That actually helped a lot, because then the local caching, memory caching on the database was more tuned to, either read loads or write loads.
Mm-hmm. Now, Reddit and Netflix both have open sourced some of its tools. When do you think it makes sense for an app like that to open source?
That is an interesting business decision. So at both Netflix and at Reddit, what we realized, different stories, but at Reddit, the story was, we know that the value is in the community, not in the software. And so we wanted the community to be able to see the software, one, so that they could potentially help out, and two, because a lot of people had questions about how it worked. And so we wanted to show them by being like, here's the code, now you can see how it works. And also because we wanted to give back to the community, because we were using so much open source that it just made sense for us to open source. Because a lot of people would ask us, like, oh, hey, you're the biggest website running tool XYZ. How do you do it? And so by open sourcing, we could be like, oh, here's an example of how to do it. For a while, I think we were the biggest site on pylons. And so people would want to see sort of examples of how to run high-scale pylons, things like that. Mm-hmm. So that was the motivation there. At Netflix, it was more of a, hey, this stuff the general rule in Netflix is if it has to do with programming or computers, it's open source, and if it's movies, then it's not. So because we know that the value in Netflix is in the curation and the content and things like that, and so we knew that sharing how we did it was kind of the same story though, right? We wanted to share how to run these things at high scale.
Mm-hmm. And that's extremely helpful. Like the Simian Army, for example, and Atlas, all those tools are extremely, extremely helpful. So by giving back to the community, you help out a lot of people. So that's fantastic.
That was the idea, yeah.
So in case anyone is wondering, we ended up shooting this interview 2 different times, which is why I'm wearing this different t-shirt and Jeremy has a different haircut. So just so you're not freaking out wondering what's going on. But following up with the first part, the discussion with Reddit, Jeremy, it really sounds like you had a lot of fun at Reddit. Why did you decide to quit it and go to Netflix instead?
Well, mostly because I had been there for 4 years and I was just the last person left there from the original group. The seniority at the point where I left was 4 years, 4 months, and so on. So it just felt like a good time to go, and we had just hired a whole bunch of people that were able to help out, and it was just a good time to sort of make the transition. And I'd been doing it for a bunch of years, and it was just time to move on to bigger and better challenges.
Yeah, try something new. I get that. That makes a lot of sense. And Netflix has been very reliable in my experience. I watch it every so often during the week, and I never really have any issues with buffering or anything like that. And they transfer so much data. It's an insane amount of data to the user and from the user. And we see sites with less traffic go down more often. So I really want to learn how you guys were able to do this. And so what I want to focus on in this section of the interview is, just like I said, how do you do it? What's the secret? And let's start off by talking about the Netflix architecture. Can you paint us a picture of what that looks like?
Yeah, so the secret is magic. The Netflix architecture is a microservices architecture. And that's really where a lot of that reliability comes in. The other secret is testing. So I'll talk about the architecture first. So it's all microservices. It didn't used to be. It used to be one big monolith, but it got broken out into services. And the advantages that services provide help a lot. So you can scale each service independently. You can develop each service independently. You can debug them independently, which limits the scope of debugging. So it helps a lot during outages, because once we can zero in on a particular service that is causing a problem, it's a lot easier to debug because you know that it's just that service and there's just a small scope. There's also the independent scaling, so each service can scale independently as necessary. And then there's just the general architecture of sort of what I like to call doing everything in threes. So we use 3 availability zones, or I should say, use 3 availability zones per region, and multiple regions as well. So it happens to be 3, but that's not actually necessary. And then being able to withstand the loss of an entire zone, it makes it much more reliable. So because everything is architected with this idea of being able to run with the 2 of 3 zones, that makes it much more reliable. And the way we know that it works is through testing. So all the testing is done in production. There's the Chaos Monkey, which is killing just individual instances, and the Chaos Gorilla, which is doing entire zones. And the secret there is practice, right? You would joke about 20 years ago about the sysadmin who took backups but never restored them. That means they didn't actually take their backup, right? So today it's you if you don't do your testing, then you're not going to know whether you're reliable. And so that's a really important part of it.
So why doesn't everybody use this kind of microservice? Why is Reddit still using a monolithic architecture instead of going with microservices?
So there's a lot of overhead to doing it. There's a lot of overhead to running a microservice architecture. You need to have a platform to do it upon. So what I found talking to a bunch of different companies is basically anyone who is doing microservices is spending about 25% of their engineering effort on their platform, on running their services. So that is a big overhead and a big reason a lot of smaller companies don't do it, and a lot of bigger companies take a while to get there. Incidentally, the company that I just founded is here to solve that problem. That is exactly the problem we are trying to solve. We're trying to essentially bring that platform to everybody so they don't have to spend the time building it.
And this is CloudNative you're talking about?
Yeah, CloudNative.
So how do you make sure that Netflix can scale to spikes in traffic then? Do you just spin up more services? Because obviously that seems very expensive if you always keep the same amount of machines even though you don't need them. How does that work?
So the trick is in autoscaling. There's the autoscaler. There's two kinds of autoscaling. There's reactive autoscaling and predictive autoscaling. Reactive is the kind that Amazon provides, where you can say, when this particular measurement gets too high, launch more instances. Predictive is something that Netflix actually built for itself, which essentially predicts how much traffic is expected to happen and then scales up ahead of the prediction. Mm-hmm. And the nice thing is that the quicker you can get your boot up time, the smaller overhead you need to have. So if your boot up time is 5 minutes, then what you need to do is you need to make sure that you have enough infrastructure to handle the maximum predicted increase in the next 5 minutes. But if your startup time is 30 seconds, then you only need 30 seconds worth of overhead.
And so you can do that with Netflix because it's that predictive. Like you're able to actually predict, okay, at these times during the day we have more traffic, we're releasing this show, etc. So it's that precise. Yeah.
So the predictions are actually, there's a lot of complicated math behind them, but it's very smooth. The curves are very smooth. People's watching habits are very regular, so they're actually fairly predictable. Like you can predict. It's pretty much just a very smooth curve up and down throughout the day. The main exception being Saturday morning. There's just a huge spike as all the kids jump on to watch TV, and there's an interesting little spike at every hour. So right on the hour mark, as traditional linear TV, whatever show just ended, people will jump on to Netflix. The really interesting stuff to predict is around things like the Oscars and the Super Bowl, because those cause really weird viewing patterns. Mm-hmm. Like the moment the Super Bowl ends, Netflix skyrockets.
Wow, yeah.
Because everybody has been using their big TVs to watch the Super Bowl, and as soon as it's over, they're like, well, now what are we going to watch? Oh, let's turn on Netflix because it's Sunday and there's nothing else on TV.
Right, and entertain the company that's at the house.
Exactly.
That makes sense.
That are sitting at the house or whatever. Yeah.
That's funny. So you talked about the time it takes to provision a machine like this, and I've heard you talk about baking. Mm-hmm. And how that's different from bootstrapping or another technique. So can you tell us a little bit more about that process? What is baking?
Yeah, so it's interesting. In Netflix, we believe in fully baked images. So essentially what that means is a machine that when you turn it on, it's ready to serve traffic. It just boots up and is ready to go. It doesn't have to download any code. It doesn't have to download any configuration. Mm-hmm. When I first got to Netflix, I was shocked that this is how they do everything. Right. And I was like, this feels terrible, but I learned to love it. It really helps with, one, reducing startup time, and two, homogeneity. It means that when I'm running a cluster of machines, I know that all of those machines are identical. I don't have to worry about whether one of them got an update yet or not. And when I deploy new code, I don't have to worry about, how has how's that code role going, which machines have which version, et cetera, et cetera. Mm-hmm. So there's a lot of advantages to it. It essentially means the biggest downside to it is rapid development. So you have to wait for the bake to finish. You're essentially taking the startup configuration time and putting it all in the front. So it does slow down development a bit. And so some people do have workarounds where they'll push code directly out as they're developing. And then the final step will be to bake a machine image and make sure that it works fully baked.
So would you only use baking like this at a Netflix scale? Or when does it not make sense? Is it just when you don't want to sacrifice the development time?
So it really makes sense for everybody. But there is the big trade-off. So when you're early on, it probably doesn't make a ton of sense. But at the same time, it still does because you still get the operational benefits from it. There's definitely a happy middle ground. And I know that Netflix is moving towards potentially using something as containerization to speed up the whole process. So the containers will be baked into the machine image, but then as you're rapidly iterating, you can quickly iterate on your containers faster than you can your fully baked images.
Okay. I've got a question from user at Reddit username Mustang2002, and the question is: do you foresee any limit to how much you can expand the current system before needing to do a major overhaul?
At Netflix?
Netflix, yeah.
That system is pretty robust the way it's been designed. There's always small changes to be made as new scaling limits are hit, but I think that one will have a lot of years left in its growth.
Do you think that's because they switched to a microservice architecture?
I do, and it's because what it means is that if any one particular service starts to have scaling issues, they can re-architect that one service to match, to meet their needs. But the whole system doesn't have to be re-architected.
So Jeremy, I want to take just a really short minute to share a message from the sponsor, Rollbar. And I mentioned Rollbar at Scale Your Code during the intro, and I'm making all of our error handling use it now. Here's why. Say if we have a potential sponsor like Rollbar, for example, that submits a request through our site, but our third-party email API just stops working and returns an error. Without Rollbar, I'd probably lose that error message forever. With Rollbar, I can log it with all the submitted details, go in the dashboard, pull out the contact info, and form a relationship. What about errors in development, or errors that make it out to production, your users keeps running into them, but you don't even know they exist? With Rollbar, you can see exactly what time they happened, how many times they happened, what line of code caused it, what deploy, who deployed it, and so much more. Go to try.rollbar.com/SYC. It takes 5 minutes to set up. I set it up with Laravel, super easy. You could do it with any other language, any other tool. Go to try.rollbar.com/SYC. Thanks for sponsoring the show. So Jeremy, how important is tracking at Netflix and Reddit?
You mean this type of error tracking that Rollbar does?
Yeah.
It's actually really important. In fact, at Reddit, we built a very similar system, very poorly, but we built a very similar system that essentially fingerprints error messages and tells us how often any particular error was happening. So I'm actually really excited to see Rollbar because it's like a commercial version of that thing that we built for ourselves. But it was super handy because you would be able to see that a particular type of error suddenly increased. At Netflix, we sort of look at it at a bit of a higher level than the errors coming out of the code. Generally, we're not looking at the errors in the code unless we're trying to debug a particular problem. We're monitoring more high-level application metrics. So that comes from both the server side and the client side. At Netflix, we have a nice advantage in that we control the client. So we can put a lot of instrumentation directly into the client. And then that feeds right into the Netflix system. And the nice thing is that since it's coming from the client, it's taking a different path to get into the system. And so we can actually have alerts on comparisons of the same metric monitored from the client side and the server side to let us know if there's a mismatch. So play starts is one of those, right? We can monitor when someone hits play on the client side and when we have received that message on the server side and make sure that they're tracking in line with each other, for example.
So when we just started talking about Netflix, I spoke about how you transfer data to the user and then from the user back to Netflix, such as the when you click the play button, how long does it take to load the video, that sort of thing.
Yeah.
How do you handle that much data going back and forth like that?
Yeah, so we like to joke that Netflix is a logging service that happens to play movies. And there's a ton of data coming back in. And luckily, a lot of that is just handled by Amazon. So, because it's horizontally scaling right there on Amazon, it's never been a huge problem to deal with the incoming flow of data. It comes into basically two different places. It comes in, there's one endpoint for all of that, the client-side logging, and then the other endpoint is the API. So the API is basically the one front door to all of Netflix for all of the clients. And so the API service is just really good at scaling. They represent a good chunk of the infrastructure at Netflix. And so a lot of it is just coming in through the API, and then it's being spread out to the various services that need whatever information is coming in.
So do you have multiple different load balancers? So you have a front-end load balancer where your users go ahead and then it selects which API to give the request to, and then you have other load balancers that talk to the rest of the microservices? How does that work?
Yeah. So essentially, when you hit the API, you're going to hit an ELB, an Amazon ELB, and that's going to direct you to Netflix's own internal layer 7 load balancer called Zool, which is actually open source.
Oh, okay.
And what that does is it routes based on request type, as well as having the ability to write small chunks of code to do more advanced routing. And then that will route it to the appropriate API machine or potentially backend service. But then within the API machine, it will it'll do all the processing and reach out to all of the services behind using an on-instance load balancer, which is also open source, called Ribbon. And so it'll hit that load balancer, and that will farm out to all of the microservices behind. And so the API is really interesting because what it can do is to enable rapid iteration for the UI teams. They can actually write small chunks of code to create their own API endpoints for their service. So they can say, like, here are the 20 things that I'm going to need to know. And so they'll create a single API endpoint that returns all 20 things in one request. And then that code actually runs on the API machine. And it will farm out the requests and gather all the data and bring it back and send it all back in a single answer.
How many machines are we talking about here in general?
Thousands. The API,
Thousands.
The API farm itself is thousands.
Wow, that's a lot of machines.
Yeah.
So what's the secret to serving so much video content? I mean, I have these video interviews. I'm able to offload that to something like YouTube or Vimeo, use their bandwidth. They take care of the CDN and all that. How does Netflix do it? Because they have to do all the heavy lifting. What's the secret behind serving video?
Yeah, so at Netflix, they cheat. The video itself doesn't come from Amazon. It comes from a CDN. It used to be coming from Limelight, Level 3, and Akamai, but now it actually just comes from the Netflix CDN itself.
It's called OpenConnect, is that right?
Yeah, so the OpenConnect project is... So the way we've built our CDN is actually open source, and essentially these are machines that are highly optimized to deliver large files, and that's it. They're so optimized for that, in fact, that Netflix still uses Akamai for all of the small assets because it wouldn't make sense to use the Netflix CDN because it's so optimized for serving large files. And essentially, those are just physical boxes with lots of disk drives spread out all over the world in various tiers. So, like in one place, there might be a data center with a couple of racks that has the entire Netflix library, and then there might be another data center somewhere that has like maybe the 80% most popular stuff. And so when your client is trying to watch a video, if you're watching the really popular stuff, you'll be directed to the CDN closest to you that has that content. So the longer tail the stuff you're trying to watch, the further you basically have to go to get that content. And then the client has intelligence built right into it that essentially determines which place to grab the video from. So the API will send back and say, the video that this person is trying to watch is available on, say, these 10 CDN servers. At that point, it's up to the client to pick the one that it feels is best. So it actually will test them all, determine latency, and it'll keep running those tests throughout the video process. And so that's called and so it'll switch automatically between CDNs and between bitrate levels and quality, basically. So that's the whole adaptive streaming. So it's always doing tests and determining what sort of level of bandwidth it's able to get and getting the highest possible quality at the lowest possible latency.
So CDNs is really the magic in serving this kind of content?
Oh, yeah, absolutely. And that's for static content, recorded content like this interview.
Sure.
Live is a totally different ballgame.
And I think I read somewhere that they're run on Nginx, right? Is that right?
Yeah, so there's super highly optimized Nginx boxes.
Okay. And what's the difference between a service like Akamai or OpenConnect and CloudFront, for example? Did you guys ever use CloudFront and then move to something else?
So CloudFront is just another CDN, very similar to Akamai. It's not optimized for large video. Okay,
so it's not as performant if you have large videos like that?
Well, nobody's as performant as the one that was built specifically to serve Netflix video, but for serving Netflix video. Yeah.
And here's another question from username Chef Lady Boyarde. What advice would you give to someone looking to build a video streaming site?
Well, if you're just starting out, there's probably going to be other options for you to leverage. But if for some reason you want to totally build your own, look at the big CDNs because they'll definitely get you bootstrapped and get you started. They served Netflix well for many years, and don't try to serve it out of Amazon yourself.
Let's see. Any other tips and tricks you can think of, or is that really the secret sauce right there?
Yeah, I mean, serving a video site is really no different than serving any other type of content. It's just a large file, like serving any other large file. So there's really no tricks or tips that are unique to video in that respect, at least recorded video.
So what would you say was your biggest bottleneck that you had to deal with when you were there?
The biggest bottleneck is probably just the speed at which we could horizontally scale. So when a big spike in traffic came in, right, it's getting that startup time down and dealing with fan out in the API, right, is reducing the number of back requests that happen in the back end to come up with the same answer. So like redundant calls, for example, trying to reduce those things like that.
And the baking as well, reducing that time that it takes to get those machines up.
Reducing the bake time definitely helped. That one wasn't a huge issue, but
okay. Can you tell us a little bit more about the Simian Army and what you're able to test with that and how to get started using it?
Yeah, so the Simian Army basically tests your ability to withstand various types of failure cases that happen in any distributed environment. The Chaos Monkey tests loss of an instance. Chaos Gorilla tests loss of an entire data center, basically, and it goes from there. Those are kind of the two really important ones, along with Latency Monkey. So that's the big one, because in a distributed environment, there's going to be two types of outages, right? There's going to be not available and slow. And not available is actually fairly easy to detect. It's either there or it's not. It's slow that's actually really hard to deal with, because first of all, what is slow? Well, it depends on the service, right? It depends on what you expect that backend to do, how long you can wait for that backend. So it's kind of different for every single microservice that you're hitting. So that's one, is tuning those numbers, figuring out like what's your timeout, what's an appropriate amount of time to wait for an answer, or things like that. And so Latency Monkey is just really handy in testing that kind of thing, because it induces latency to the request, so you can see where your system breaks down. Because that's typically where you're going to get a breakdown in a distributed system, right? The biggest expense of a distributed system is moving data from one place to another. So when that slows down, that's going to really affect your entire performance.
And you mentioned earlier how you guys have 3 different availability zones, and you will literally go in and cut one off, like destroy or shut one down, just to see how the other 2 are able to handle it, right?
Yeah, actually shut down all the instances in that third zone.
And that's the same thing with Chaos Monkey, where it just deletes random instances, and that way you can see how the other ones are able to withstand the shock and things like that.
And originally, Chaos Monkey would find a lot of problems, but nowadays it barely finds anything because everyone knows it's coming, which is exactly what you want, right? But you're never going to stop running Chaos Monkey, because then you get complacent and you don't know that your system still works.
Right.
So all of these testing systems, the goal is when you first run the tests to find the problems, and then to continue running the tests to make sure that you haven't introduced new ones. It's essentially a form of regression testing. You want to make sure that you haven't regressed in your ability to withstand failure.
Can you think or remember back to one of the issues you saw from using Chaos Monkey? I can't even say that word. Chaos Monkey. And that just shocked you the most? You didn't expect to see that kind of issue?
I can't think of one where Chaos Monkey caused a huge problem. By the time I got there, even Chaos Monkey was already pretty effective in getting people to do the right thing. There were definitely cases where Chaos Monkey would run and somebody would say like, my entire thing died. And it's like, well, that's because you were saving all of your critical data on a single machine. So you've learned your lesson. But the Chaos Gorilla has found some really interesting stuff about, basically issues about how the requests were not being distributed evenly, or the data was not distributed evenly. And so when you lost a particular zone, suddenly the other 2 just got far too overloaded to handle that issue. Most of them are now solved. The interesting work now is happening at the Chaos Kong, which is the one that actually it doesn't actually shut down whole regions, but it rapidly shifts traffic away from one region to another.
And that's still causing issues to this day. Yeah, they're still working on.
Well, that one still definitely is surfacing things. They're not really, they don't really cause customer-facing issues at this point, but it's definitely doing a good job of still surfacing new issues, particularly are just around synchronizing 2 different regions, right? How do you handle when the traffic suddenly jumps from one region to another to make sure that experience still works?
So part of, for example, site reliability engineer's job or chief architect job is to automate as much as possible, right? Can you think of things that you guys were able to automate at Netflix that most people don't really think about automating?
Well, see, that's a tough question for me because when I think about doing stuff, it seems like a no-brainer, but then I talk to other people who are like, oh, wow,
Right.
that's an amazing idea. So, like, so a lot of the stuff that people are surprised that we had automated are even things like deployment, right? Continuous deployment, continuous delivery. A lot of people still aren't doing that kind of thing. Automating the auto scaling, right? That's a huge thing. Auto scaling has existed at Amazon for a long time, and very few people use it. Automating.
Why do you think that is?
Because it's hard. It's hard to get right. It's hard to tune your autoscaler. It's hard to figure out when it's working correctly. It's just hard to do it well.
That seems to be the recurring theme in this interview specifically, where, when you have a smaller team like that, it's just you don't have the resources to really work on or to really come out with the solutions that will solve long-term problems, right? You kind of have to patch things up, and then as you grow the team, as you grow the revenue, then you're able to actually do what the big companies are able to do, like Netflix, for example.
Right. Yeah.
Mm-hmm. Earlier, you talked about how it takes longer to do changes in your development and infrastructure. Can you walk us through the entire process, or not really the entire process, but the general process of changing something in the infrastructure at Netflix? What happens when you try to do that?
So are you talking about like deploying code or?
Yeah, deploying code, for example.
Yeah, so deploying code, the way that works is you check in your code to the repository. That kicks off a bake, which essentially builds a full machine image that will run your code. And that bake takes a couple of minutes. So if you are trying to rapidly iterate, that's where you're going to get stuck. And so because it'll bake that image, launch it in test, you go and you run your test, and then you launch it in production.
Okay.
So there's sort of a flow there. And there is automation coming to more automation being added so that entire flow happens automatically, but you're still going to have to wait for it. And so what a lot of people do to speed that up is, they'll have their machine running in test, they'll make their code change and just immediately copy it off to the test environment, push the code out directly, and then run the tests. And that works pretty well because, especially if you're just making application changes, you're going to be pretty safe with that. And then once they get it going in test, then they will launch it, make one fully baked, put it in production. Sometimes people will actually get to the point of pushing it straight out to production as well, just to get, they need the production data or they want to see production traffic or whatever. It's totally up to each team how they decide to run their development. Some teams are very loose with their, just straight up developing right on production machines. It's up to each team to decide. The main concept of Netflix is to provide the tools to developers to make it easy for them to do their job, but it's up to them to decide how they want to do their job.
Right before I forget, I was going to say that if you're interested in learning more about continuous integration and delivery, check out my episode. It's a few episodes back. I don't remember which one it is, but it's with the CTO of CodeShip, and we talk about how that works and how they make it happen at CodeShip and other companies like Circle CI and things like that. So definitely check that out. But as you just said, Netflix maintains a culture of freedom and responsibility, as I saw it. What does that mean? How is this different than regular companies or other companies?
So the way it's different is that it manifests itself in interesting ways. The idea is that, you are a responsible adult and you have the freedom to do what you think is the right thing to do, and then you have to take responsibility for those decisions that you made. Mm-hmm. So, if you think the right thing to do right now is to deploy your code directly to production without testing it, that's up to you. You can go do that. Nobody's going to stop you. Now, if you break all of Netflix because of it, you're going to have to take responsibility for that.
Right.
And if you don't, then great, you've succeeded in your task. But that's the general idea behind everything, and it's pervasive throughout. I mean, it goes to the expense policy, right? The expense policy is do what you think is the right thing to do. And if you go and you spend thousands of dollars on too much liquor or something, then somebody's going to tell you that you need to be responsible for that. But nobody does, because they know that they have to be responsible.
Sure.
But it's just, that's the idea. The idea is to get out of people's way. Like the security group at Netflix, they don't approve anything. They monitor, they scan, they suggest, but they're never a block. You never have to go through security to get something done. It's always security makes suggestions and provide tools to help you make the right decisions, but it's ultimately up to you to make the decision.
I want to talk a little bit more about how you hire people, especially engineers, as you were a chief architect at both Reddit and Netflix, the whole process behind that. But right before I do that, I wanted to mention that you used Cassandra at Netflix too, right? We spoke about it for Reddit. Can you tell us a little bit more about what kinds of data you use Cassandra for and why you chose Cassandra?
So at Netflix, Cassandra is basically the main data store for pretty much everything. There's an entire team of people who run the Cassandra infrastructure, and so it works really well. So pretty much everything is stored in Cassandra.
That speaks volume for the software. That's for sure.
Yeah. Well, it speaks volume for the team that maintains it as well.
That too. Yeah, definitely. All right, let's talk more about CloudNative. I'm really curious about why you co-founded this company. What's the vision behind it? The
vision behind it is to essentially eliminate that overhead that we talked about before. It almost sounded like you were shilling for me before when you were talking about why companies don't do microservices. But we swear, you haven't been paid to say that.
No, I was not.
That was the idea. That's the idea behind CloudNative, is to essentially bring the sort of architectural style of Netflix, Pinterest, Airbnb to the masses, to everybody. So that, because we think that it is the right way to build an infrastructure for long-term reliability and scalability. And a lot of startups want to build it that way, but they don't because of the time and cost of doing so. So by providing this platform, the startups can use it from the get-go and have it throughout their life. The enterprises who want to move to the cloud can just jump over and do it. And the people who move to a new company and have built this 3 times at their last 3 companies could be like, you know what, I'm really tired of building a microservices platform. I'm just going to use CloudNative to do it instead.
I see what you mean. That does sound exactly like what I was just talking about earlier.
Yeah.
So this is not just for larger scale companies. This is also for startups, smaller businesses, right?
Yeah. The idea is that it'll apply to everybody. In fact, it's really great for startups because it can get them on the path of microservices right from the beginning.
So that's where most of your clients are or customers are?
Well, no, it's actually across the mix, but
okay.
That's one group that might find it particularly compelling.
Here's another question from user name Will R. Stern. What are some best practices you've learned to keep deployments as simple and as bulletproof possible, especially when deploying major infrastructure / data alterations? I feel like that kind of ties in with that.
Yeah, so the best practices are, so for data, the best thing that I found is you deploy you don't try to do like a stop the database and change the table kind of thing. You do an intermediate step where you bring up a new table that has the new schema, and you start you write a chunk of code that essentially knows how to read and write to both old and new. And so every time a request comes in, it does both. And then you have a back channel process that migrates the data from the old to the new that hasn't been migrated through the code, just actively doing it, because that will give you a no downtime schema change. And so that seems to be the best way to get a no downtime schema change. Now, you can just take a downtime and make a schema change, which can work, but can be risky if it fails for some reason.
And I think, sorry, go ahead.
Oh, no, go ahead.
I was just going to say, I think it seemed like I read that the service is not just for baked AMIs or images, but also for clean installs with Chef and Puppet, right? You can support all those different ones across the board. It doesn't have to be just baking.
You're talking about CloudNative?
Yes, yeah.
Yeah. So CloudNative, right now, the system is designed for fully baked images, but you can use Chef, Puppet, Ansible, etc. to create your image.
I'm going to have to do some more playing around with that. That sounds like a very interesting concept, the whole baking concept and all that.
Yeah, so the nice thing about what we built the CloudNative is that then once you have your baked image, you have a deployable unit. And so you can then go and create clusters with auto scaling, and we do all the auto scaling for you. We set it all up and manage it for you.
And this is cloudnative.io if anybody wants to check it out.
Yeah.
So Jeremy, how do you get the skills necessary to work at the scale that you've worked at? Do you have to just crash a party at Y Combinator or with Paul Graham and get to know some startup? How does it work? How do you do it?
Well, actually, crashing the party does help. Although, to be fair, I didn't crash the party. I was invited.
Sure.
But no, that does help. A lot of the stuff I learned just by doing it, by essentially finding any opportunity to do something new and different and taking that opportunity. So, when I started my career, I was in IT, and I would look for any opportunity where somebody needed a new server set up or, some new thing set up. And I'd be like, yeah, I'll do it. I'll learn it. I'll spend extra time to figure it out, on my own time and do it. I ran a bunch of infrastructure at my house so that I get a lot of experience that way. Really, the best way to learn this stuff is to just do it for something. If some company doesn't want you to do it for them, go and start your own project and do it, for yourself. Start a little hobby project. You'd be surprised how much work is involved just in a hobby project. That's a lot of how it was learned, and just making your own luck, right? Is find an opportunity and go seek it out. Like what I did with the Y Combinator guys, right? I was at that party and I saw the Reddit guys, and I went and I talked to them. And, you just gotta kind of go and seek out what it is you want to do.
So when hiring people, like for example, you want to hire a site reliability engineer or something like that, what do you look for? Do you put more stress on the technical expertise or on the ambition behind the person? How does that work?
So particularly for a site reliability engineer, what I'm looking for is somebody who has a passion for the customer and advocating for the customer and the customer experience, particularly always having a good one. So, I want a site reliability engineer who essentially wants to come in and make sure that, so at Netflix, for example, that somebody can always watch their movie. That's what I want. Now, as far as experience goes, somebody who has experience both coding and running an infrastructure is going to be the best. But, you can learn one skill or the other to some extent. Obviously, you're going to be better if you have experience. But the main skill that you need to have is this ability to handle, emergency situations, this ability to stay cool under pressure, and to really be able to step back and think about the experience from the customer. Like, how do we make it so that the customer gets their experience back as quickly as possible? And then how do we go and diagnose and fix this issue? So that's really important. Is what a lot of people kind of get stuck on is, I need to figure out what broke. And so they'll start diving in and looking at logs and whatever. And it's really important for you to understand, that's great, but more importantly, I want you to get our customers back online first.
That's an interesting thought. I like that. One more question. I thought I had more questions, but winding down here. And again, this is from username Will R. Stern. And this, I feel like this is a good loaded finishing question. What are some scaling anti-patterns pertaining mostly to architecture, like microservices, service-oriented architecture, etc.?
So scaling anti-patterns, essentially you're looking for things that people would be surprised about doing, right? So I'd say that the fully baked images is probably one of those that people don't think of, at least. It's actually a pattern, but people probably think of it as an anti-pattern. The other anti-pattern would be different data stores for each service. So that's actually a big pattern for microservices, but a lot of people think that, so a lot of people want to build, they have their single database that has everything to do all their joins, but that is just going to get you into trouble, because then you still have your single point of failure. It's just further back in the stack. So dividing up your databases, one database per service, basically, so that each one can do their own. And if you need to join data between them, then that gets moved down into the software. So that's the really important part, right? Is if you need to join data from multiple databases, that's happening now in the software instead of the database.
Yeah, this was a really cool interview because we got to see two different giants, the Reddit community, and you have the Netflix, and they all have their own technical challenges. And thankfully, you've been able to participate and seeing the growth of both of them. So it was really good having you on the show, Jeremy. Yeah. Really appreciate it. If people want to get in touch with you, how should they do that?
They can just send me an email, jedberg@gmail, if they want to get in touch, or they can hit me on Twitter, although I'm not always looking at my Twitter, so.
Too busy working, right?
Yeah, I guess.
Sure.
Well, I'm just more on email than Twitter, I suppose.
Sure. Okay. Yeah, and again, check out his company CloudNative.io. They're working on some really interesting pain points, so do check that out. And thanks everybody for watching. If you enjoyed this interview, if you learned from this interview, please leave a comment and let Jeremy know how much you appreciate it, because I certainly appreciate it a lot. Thank you, Jeremy.
Thanks.
Hope y'all have a wonderful day.
You too.
Take care.
Bye-bye.